This machine is called a belt sander. The blue surface you see here is a belt coated with abrasive. The belt that's in this machine looks like this. It rides over a pair of pulleys. The top pulley is just an idler pulley up here, and in the bottom of the machine there's a similar pulley that's attached to a motor. This machine is very useful for sanding a variety of materials. It's excellent for sanding wood, most metals, aluminum, steel, brass, and also for sanding some plastics. I'll demonstrate now how this machine is used. Whenever possible, you should support the part that you're sanding on the bed of the machine. As you're sanding the part, you want to move the part back and forth across the surface of the belt. This gives you a smoother finish and eliminates hot spots in the belt. We've now smoothed down this surface and rounded the corners of the part. The edges, however, are still quite sharp. To smooth down those edges with the belt sander, it's necessary that we hold those edges on an angle to the belt. With relatively thick parts, say a half an inch or thicker, it's reasonable to do this by propping the part up on the bed of the machine and bringing it in contact with the belt. As you notice, there's a little bit of a gap here. In fact, this machine is set up with too large of a gap to be very safe. The danger here comes in with thinner materials like this. You see, with a gap like this, it's possible to have this part just get sucked down behind here by the force of the belt. If you're lucky, all that will happen is that the part will disappear inside the machine. If you've been holding the part like this, your fingers tend to want to go along with it. So especially with thin parts, it's a good idea when you're smoothing the edges of the part to do that up and away from the bed. Holding the part up here, if the belt tends to pull it down a little bit, it's just moving down into free space. Something else you want to be careful about is the angle at which you hold this part relative to the belt. This is safe. This is incredibly dangerous. What can happen here is the belt can again grab the edge of the part, drive the part down, and very easily cut off your fingers. So never, ever sand a part like this holding it up at this angle. Always at this angle. Now I'll demonstrate this. Now we've achieved a smooth surface on the sides of the part and have deburred the edges of the part. If you look closely at the bed of the machine, after I finish sanding, there's some dust left around the machine. Aluminum dust is not a problem. Other materials, however, can produce toxic dusts or dust that cause allergic reactions in people. For this reason, we have a vacuum attached to this machine. Most of the dust, in particular the very fine particles that are more likely to cause problems, are drawn into the vacuum. These larger particles tend to just sit down on flat surfaces and can be swept up. In addition to using the vacuum, it's also a good idea to wear a dust mask. We also have a small belt sander in the shop that basically serves the same function as a large belt sander, but the structure of the machine is a little bit different. Notice in particular we have access to the back side of the belt. This makes it possible to sand surfaces of notches and grooves we put into parts, like this. This machine is also reconfigurable to sand on different types of surfaces. Loosening up this bolt allows us to remove the table like this, giving us more access to the belt. And now if we remove the platen that supports the back side of the belt, you can see rather than having this stiff flat surface of the steel backing up the belt is now soft, a little bit baggy and flexible. If we're doing something like rounding off the end of a piece of stock, making a very smooth contoured shape, you'll find with a hard platen on the back, you tend to put facets in the part, little flat spots. But in this configuration, the belt has a lot more flexibility, and sanding a shape like this, you'll get a much smoother surface. Other ways you can reconfigure this are moving the position of some of the pulleys, like this. Locking that in place. Now with this out at the front of the machine, we can very easily sand the inside of concave surfaces. Trying to sand a concave surface like this on a flat belt simply produces a couple of notches corresponding to the edges of the belt. But here we can produce a nice uniform radius. Another configuration that's used occasionally is to simply set up the belt on two pulleys. Adjust this a little bit to get a little more tension on the belt. Down here. This is convenient for sanding very narrow slots because this allows us to sand both sides of the slot at the same time. The thing to keep in mind with a machine that has this much flexibility in it is be creative. Try different positions and see what works best for you in your particular application. This is a grinder. A motor in the middle here, and attached to either end of the motor are a couple of grinding stones. We have a coarse stone on one side and a finer stone on the other. In many shops, a grinder like this is used for many different operations. In fact, most of those operations are best done on a belt sander. If you're deburring a part, grinding on this narrow stone, if you're removing any amount of material at all, you start heating up the part and heating up the stone. If Do the same operation on a belt sander with a much larger area of the belt. The whole operation goes much quicker, and you keep the temperature of both the abrasive and the part much lower than you will a grinder. Really, the only purposes for a grinder like this are for sharpening tools, typically that are made from tool steel. For example, you can sharpen something like this, a drill, on a grinder. Trying to sharpen a drill on a belt sander causes a problem in that as the belt is coming down across the front of the drill, because the belt is slightly flexible, it tends to move around a little, kind of round off the cutting edge. You can avoid that problem by using a grinder with a very hard stone so you get a nice crisp cutting edge. Here's a file you can't buy in a store. I had a strange application where I needed to get down inside a pocket and do some filing. While I was there, a normal file has a square end on it. I was concerned that that end was going to gouge into the part. So what I did was grind down the end of this file so that I'd have a smooth edge so that I could rub up against the side of the part without damaging it. I also made another little modification here to get down deeper inside the part. Just heated up this part of the file with a torch and bent it slightly. Many shops are switching over to using tungsten carbide inserts for most of their tools, for their lathes and milling machines. So when an insert like this gets worn out, you don't need to sharpen it. You just turn it to another side, put it back in, lock it back in the tool, and you're ready to go. There's still occasions when you want to use a standard high-speed steel tool. A tool of that shape can be purchased in the form of a tungsten carbide insert. You don't need to make a tool like this anymore. On the other hand, a special tool like this is not something that you can buy made out of tungsten carbide. A tool like this can very easily be made on a grinder, grinding these faces, the sides, and also the groove that's running down the middle of the tool. What's this tool used for? Well, got a cribbage board here. Cribbage peg. This tool neatly fits down inside these grooves. One of the students in this shop wanted to make a set of cribbage board pegs out of aluminum, brass, copper, and stainless steel, so they made this tool so that they could make these pegs. I said before, people use the stones for a lot of purposes that are better done on the belt sander. Not that you're going to damage the stone or damage the part, you just get a better job if you do it on the belt sander. There are some materials, though, that can cause major problems if you try to grind them. In particular, the big no-no with grinders is grinding aluminum. I'll show you what happens here. So if you look closely at the stone, you can see that there's aluminum embedded in the stone. What's happening here is the stone grinds the aluminum for a while. The particles get embedded in the pores of the stone and stick. The next time the stone comes around, there's no grit exposed. There are little bits of aluminum. The aluminum just smears on the aluminum, producing more and more heat until the stone fills up. So really all you're doing is smearing the aluminum on the aluminum, and there's no grinding going on at all. Natural reaction, because there's no grinding going on, is to push a little harder in the hopes that something will happen. no grinding happens. What does happen is the friction between the part and the stone heats up the outer edge of the stone fast enough so that occasionally a stone like this will explode. That's why we have the guards on here to catch the shrapnel as it comes out of the machine. An easy way to avoid this problem is don't try to grind aluminum. So aluminum is firmly embedded in the wheel, but the wheel isn't destroyed. We don't have to replace it. What we do is just simply dress the wheel. This dresser has what are called star wheels in it that are free to turn. These are actually fairly soft steel and much softer than the stone. The way this works is this turns around. Each of these little teeth pounds on the wheel and actually breaks up the wheel. It doesn't actually trim it down at all, but it's like thousands of little hammers pounding away in the wheel and gradually wearing it down. You can see, looking at the stone now, with just a few seconds work with the stone dresser, cleaned up the stone and removed all the aluminum that was embedded in the surface of the stone. In addition to a grinder, our shop has a deburring wheel and a buffing wheel. The buffing wheel, you may be familiar with, simply a stack of pieces of cotton cloth. You apply an abrasive to the wheel and use it to put a very fine finish on metals and plastics. The wheel on the other end of the machine is a deburring wheel. This is sort of halfway between a buffing wheel and a hard grinding stone. It's soft. Not as soft as a buffing wheel, but certainly not as hard as stone. What this material is basically the same sort of thing that you may be familiar with seeing as a pot scrubber. Some mesh that has glued to it little bits of abrasive material. The difference between these two is simply that this is a little bit denser. This wheel is very nice for intermediate finishing work. I've ground down the end of this piece of bar stock on the belt sander, and you can see the scratch marks and some facets in there from grinding up against the hard flat surface of the belt. You can see the much smoother finish achieved using the deburring wheel. You can compare that with the original finish left by the belt sander. This is actually a very aggressive wheel. The bulk of the wheel is relatively soft, but the abrasive itself is very hard. So it's possible to take materials such as tool steel, extremely hard materials, and deburr them like this. You can see I've rounded off the corners and left a much smoother finish on this piece of steel. There are times when you want to do this on just this part. You want to do a burnishing operation, smoothing down the surface, say something like brass. You do that with a very hard tool that has a very fine finish. Just force the tool over the part and achieve very smooth surface finishes that way. Other materials can be deburred with this wheel as well. left a very rough edge in this part with a bandsaw cut. You can see very quickly I've eliminated all the roughness from the bandsaw cut, left a very smooth surface. A word of warning here, just like the belt sander, you've got to be very careful to always hold the part pointing down. Holding the part up like this when you bring it into contact with the wheel risks having the wheel grab onto the part and pull it out of your hands. Worse yet, grabbing onto the part if it's a longer part and driving you down into what are supposed to be guards to protect you. And in general they do, but in this particular case you risk having a part driven down and pinching your fingers between the part and the guard. So in working along an edge like this, work from the bottom up, about halfway. Then turn the part over to get the rest of that side. Doing this, things happen very fast. At the very least, you probably damaged your part. And if you're the least little bit unlucky, you probably also damaged yourself. This caution also applies to the buffing wheel over here. Especially with this sort of furry finish on the outer edge of the wheel, this can very easily snag a part and pull it right out of your hands. This is a tube of abrasive that's used on a buffing wheel. A whole class of these abrasives meant for different surface finishes, different materials. The buffing wheel itself is just cloth, so by itself it is not abrasive. So what we do is turn on the wheel, and press the stick of abrasive into the wheel. This abrasive is mixed with a wax that melts the friction produced by pushing it into the wheel, and then it's transferred onto the buffing wheel. We're now ready to start buffing. Now we can compare several surface finishes here. Start over here, the surface finish left by belt sanding. See, it's very rough. See the scratch marks from the abrasive. And over here, the surface finish left by the deburring tool. As we come around here, surface finish gets even smoother, in fact smooth enough so you can see yourself in it. To achieve this sort of surface finish, you need to use the right abrasive. And also, when you're buffing, you need to start out fairly aggressively, pushing the part into the buffing wheel to remove all of the gross irregularities, the scratches left from whatever the previous operation was. Once those are removed, you want to gradually lighten up the pressure that you're applying to the wheel, and in doing so, the abrasive becomes less and less aggressive and leaves a smoother and smoother surface finish. There are 5 components to our shop series. We begin with a shop orientation and safety lecture you see here. This is followed by a lecture and demonstration of all the material in the basic shop tapes. The third component is a test on the basic shop skills. A shop this noisy and crowded is a very dangerous place to work. especially when it's full of people that don't really know what they're doing yet. We use this test format in order to minimize the time between instruction and testing, and also to give the students a real appreciation of the difficulty and danger of working under the stress caused by all this noise and confusion. The fourth and fifth parts of our shop series are the lectures and tests associated with the lathe and the milling machine. These lectures and demos are given to groups of no more than 6 students at a time. The students are then tested individually on each machine. This method of instruction and testing works well at the Artificial Intelligence Laboratory, but may not work well for you. The best method is strongly dependent on the maturity and motivation of the students.